All right, so for the second part of the series, we're going to focus on creating a game manager that handles our navigation through the maze as well as the interaction with the player and the walls, the win state and the fail state. Um, so, first of all, I'm going to. Um, the character here is a little too big on the screen for my taste, so I'm going to. What I could do is I could scale down the character by zero point 0.5, but I prefer to keep the scale at 1 for the player character and just change the size of the camera. You can see what I'm doing here. So the camera, instead of a size of 5, I'll scale that by 10 so it shows more on the screen like that. Next thing we want to do is we want to go into our project folder, navigate to sprites, and get our first map in there. So we can just click and drag the map in here, and clearly the map here is too small for our player character, so we can scale that up. Could try like 10, but specifically for this map I wanted to make it so that it was too tight, just too tight for the player to get through this section without rotating. So I ended up going with the scale of 8 to make that happen. Next is we want to position the player is going to start in the middle of the screen, and we want to position the map so that the circle starts in the center of the screen like this, and it ends up being close to -25, -25. I like to keep things even like that, and that looks pretty good. Next, we can place our warp hole as our goal where we want it. So I'm just going to drag this back down here. It's pretty close to 0, -50. And I prefer to have the walls be a different color. I'm going to have them be black, just like our character, so that we know that everything that's black can interact with each other. All right, so the next thing we want to do is I'm going to create an empty object to hold our new script, which is going to be the game manager. I'm just going to call this object game manager, not game manger. I'm going to put that, just organize that at the top. I can save that, and I'll add a component, which will be game manager. Create an add. The nice thing about this is like Unity detects the words game manager and has a special icon for that, which is kind of new, so that's pretty nice. Just know it's a script like any of our other scripts though. So as Visual Studio opens, let's do what we always do and go to our new script and think about the pseudocode strategy for accomplishing what we want to. So our goal is to we can do this several ways. We can move the map where we want it so that the map moves and the camera is stationary, or we can move the camera to navigate through the maze like this. We could even create an animation, create an animator. I won't do this, but you go down here, create an animator. You would start a new animation like this, and we could we could set keys for where we want the camera to be each time. The reason I didn't go with this is because every time we create a new level, we would have to create another animation every single time, and I would prefer to streamline this so we can create levels quicker, and maybe so we can just throw in new sprites and new parameters, and it would navigate through the maze like we want it to. So what I ended up the solution I ended up coming to was that I wanted to have a set of object transforms. So just empty objects that we place throughout the maze that would be like markers for our camera to move to. So it would take in basically the vector 3 in 3D space. Why don't we just create one of those right now? We can create an empty, we'll call it target. And we want the camera, we place it to where we want the camera to end up. I want this to be smooth, so I'm going to make it the same Y value as we had before. Z is going to be the same, and position here, let's try negative. I just like working with even numbers, 43, or non-decimal numbers at least. Negative 44 looks about right, so we'll do that. So basically I want this camera to be able to move to this target that I made with a certain speed. Set of object transforms as targets. We feed in the target position, move camera to position with certain speed, something like that. Ways we can move the camera in code: we can do an add force. The reason I'm not going to do that is because if I'm adding a force to the object, then I need to, it'll have, based on friction and based on how much we push it, it'll sort of float through wherever we want, and we have to attach a transform to the camera, or sorry, attach a rigid body to the camera, which is a little awkward and not really done. So instead we'll use translate. So first I'm going to declare the camera up here. We'll just grab the transform from it, and in our start function we can say, instead of making this public and having to put it in every time, we're just going to say go find it. So game object dot find, and it's going to be called what do we have it here? We can call it main camera. And then we grab the transform from that game object. So now we can manipulate the transform of the camera just by saying cam here. So you can see as I type it that it's now recognized in my sort of tool here where it autofills. We're going to use translate on that. So cam.translate. And now where do we want to translate it to? So we need to grab the target So how do we want to do that? We can declare a single target here. So like we can make this a public transform for now. Public transform target. And then we take the target, we take that transform, and that'll be the position that we want to move the camera to. So we can say target dot position, and how fast do we want to do this? Well, so we can multiply this by every time you use translate and update. It's kind of funky. You have to use multiply it by time dot delta time. So to use translate, you have to basically over time keep calling translate. So anytime you use translate, you usually multiply it by time, but delta time, and you multiply that by some speed. So we haven't declared this yet, so I'll make this a public integer or a float. That way we can be more precise if we want to do like 5.5 speed or something like that. So make that public float speed. And all of these declared variables happen outside any function. Great, so we can translate that by time.delta time times speed. So we can even just try this out. Yeah, I mean, this should do something. So if we look at our game manager, we should have some public variables if this saves correctly. So I have an error, and it's probably because I don't have a semicolon. Oh, you know what? I'm missing a parentheses, I think. Wait, no. Cam.translate. That's fine. What's our error? Oh, I didn't save. Great. And now we have our public variables here. Our target is going to be this, so we're just going to drop it right there. Speed, let's just do something like 5 and see where that gets us. So if I hit play, speed seems like super fast. Maybe we want to do like 1. Okay, even that. 25. That's something. But one thing that you'll notice is there is no interaction between these two. So maybe we'll do that first before moving on, as we'll set up some colliders for both of our objects. The nice thing about working with sprites that have transparency, I import PNGs and I use alpha as transparency. If you look into the import settings, I make that a sprite, and we're texture alpha. Oh yeah, so alpha is transparency. That is marked correctly so that we can use transparency here. If we work with a sprite with transparency, then the easy way we can make colliders around this is we make it a polygon. Polygon collider, and make that 2D. And you can see here, and this is the collider that they came up with, and it has edges is basically what we want there. It's not super precise, so if you need something really precise, maybe you would want to go in Let me just hit F so I can focus on this. Anytime it's doing that, like it's like as you zoom in, it's like disappearing. You can focus on that object so that it doesn't do that. The Unity engine is trying to figure out what you want to look at based on your zoom. So if you specify that you're going to look at something, you hit the F key, it'll focus on that and you can zoom in and it's fine. But all I was saying is if you want to be more precise, you can do, this would be a lot of work. You do a lot of little square box colliders to make that more accurate. But for the purposes of this game, this is going to be good enough. So a polygon collider for that, we could do the same for our character if we wanted to, but since it's a simple rectangle, I'm just gonna use my box collider, make sure I put box collider 2D. So if I put box collider 3D version, then 2D and 3D don't really interact. So jump cut because I made a mistake and I don't want to waste your time. So to continue where we're at, we've got our colliders on our objects. We want to now create a small script that detects the collision and does whatever we want for the fail state. So, and we'll handle that in the game manager. So this will just be a short script that sends a message to the game manager saying that the player has collided with the side. So what we're going to do is on our map, we're going to add a script. And it's going to be, I'm going to call it map controller. And it's a new script. Create and add that. Double click to open Visual Studio. Come on. There we go. Reload all. Alright, on our map controller, we don't need any start or update function. All we need is a function that Unity already has that we can use. So Unity documentation is our best friend. So I have it open here. We can open it. It's already on Collider 2D, but you can look and scroll through and find it once you're on the documentation page, which I can provide a link in this video. And it shows us a bunch of properties that we can manipulate as well as messages. So and we can find what we want in these messages. So it's not a trigger, it's a collider, so we can ignore these three until later. And then collision stay, we can read the description. So it's in each frame that two objects are touching. Collision exit is the frame that it stops touching each other. This is sent. So we want immediately when the two collide. So we'll use on collision enter 2D. So we can just copy that over here. So void on collision enter 2D. Collision 2D. They name it Cole. We can name it the same. It doesn't matter what we name it as long as we refer to the same thing here. So and what they're doing in this example is a good idea actually. So they detect if it's the if it's an object that we want to do something when they collide. So in our scene we could ignore this because the only two objects that are interacting is the player and the map. But if we wanted to expand this and we had like moving objects, we don't want the game to restart every single time anything interacts with the map wall. So so instead we'll detect if it's a player. So we can say if the Cole, so what the other collider that this is colliding with, dot game object, and we'll check for what's called a tag, and we'll set this equals not set, we will check if this tag equals player, and that's a capital P. And this is nice because this tag is already predefined in Unity, and then brackets for whatever we want to do after that. So I'll save that and just make sure that the player game object has a tag that is player. So that's great. So now if something collides and if that collision is a player, then we want to send a message. So we can just find the game object that we want to send a message to, game object dot find, and that one is our game manager. So we find game manager and dot send a message. We'll send a message, and this message should be whatever our function name is going to be, because when we send this message and game manager receives it, then it's going to call whatever function that this message is, if there is a function. So we're going to say send message fail, because if this has happened, if the two objects have collided, then that's a fail state. Okay, so we'll send a message which is fail, and now in our game manager we want to create this function. So void fail parentheses, and just to check that this is working, we'll print just print fail. And what this does is in the console it'll write out fail, so we know that this has been triggered. So now we can test it out. And no. Oh, you know what happened? Let me escape out of this. Oh, that's another problem that we need to solve. There we go. What happened is that for collisions to occur, we need a rigid body on the other object that's colliding with it. So since this isn't moving, it'll interact with the collider, which also has a rigid body. That's something that I forget sometimes, and I rack my head figuring out what the problem is, and it's just that, oops, we want the player to add a component and have a rigid body 2D. So now, hopefully we'll get that message saying that we've collided, and as you can see really small over there, that does happen. Great, but let's expand this and do whatever we want to do for a fail state. So first, I want to send a message that this is something bad to the player, and a way I can do that is I'm going to change the map to red. So anytime you hit it, it'll flash red, and it's very obvious that's a bad thing. And then we'll restart the level, so the player will understand, oh, I can't hit the sides, and it's making me try again. So we're going to change the map to red, and then we also want to reload our current scene. So reload level. Okay, so in order to do the first part, change the map to red, then we need to grab the sprite renderer of the map and modify this color that we have here. The only reason I can do this is because I have a white sprite instead of a black sprite, and I can change the colors at my whim. So that's nice working with white sprites. So yeah, so we need to grab the sprite renderer, and we need to grab the color, and we need to modify that. So in the game manager, we will we'll declare a sprite renderer. I like to separate what's public and what's not public. So just like we did with cam, we'll sprite renderer, great. and we'll say, what are we going to call that? We call that map sprite. And at the start of the level, we can say map sprite is game object dot find. Oops, not that yet. Find. Map. Oops. Yeah, we want. Let's call it map. So this should be the same on every single level. So I'll actually change the name in here from map 1. Make sure our object is called the same thing that we're going to refer to. Game object.find map, and we want to grab, so we can get a component from our game object, and we're gonna look for the sprite renderer. We need to do a double parentheses after that anytime we do get component, and so we'll get the sprite renderer, and we'll so great, we can just reference that, and now we can go back into our function. Now that we've specified what map sprite is, we can now refer to it, and we'll get the color, and we'll set it, so that's equals, not equals equals, equals color dot red. So there's some predefined colors that we can just refer to here. So if you want to change it to magenta or whatever, that's nice. If there's if it's a color that's not common and you want to sort of make it your own color, then you would maybe find the color code, either HSV or RGB, and convert it to, it works with RGBA, so 4 input 0001. With red, that's 1001 for RGBA. Alpha is 1 for solid colors. And I think that should work. So we'll test that. The next thing we want to do is reload our level. And to do this, we need to add a library. So we're going to say using. What library are we going to use? We're going to use Unity. It's under Unity editor dot scene management, right? Now that we have that library, we can say we want to load a scene. So load. How does this work? This is I think we have to say scene manager, not editor, scene manager. Oh, we don't want Unity editor, we want Unity engine. It's confusing that there's 2 of these scene managements. Now it's detecting it's in blue. Scene manager, load scene. And it takes in an integer, but I would rather refer to the name. But actually for this one, we don't need to do anything. Oh, actually, that's another way we can do it. We can just refer to the string name like this. So we'll load scene. We want to load scene, whatever the current scene is. So the nice way, there's a way to detect what the active scene is, and that is under scene manager. And if you press dot, you can look at like all the different methods that are associated with scene manager. And if we scroll, we'll find get active scene, and if we highlight that, then we can sort of double click it and see how it works. It doesn't really take any input because it just gets the active scene. And we'll find, we'll input the name, so we'll just say whatever name that is. I wonder if it'll work without the name. No. So we get the active scene and we send the name. This get active scene doesn't send an integer or a name, so we need to specify that we're the string name is attached to the active scene, and that's the scene that we're going to load. Alright, so now we can try this. See if we... Yep, we restart. Cool. Alright, so this thing is annoying me. I want to make it so that we are not having a headache every time we play test this, because we're taking over the cursor, and when we go to unpause the scene, or to pause the scene, or to stop this game from running, we have to do a little trick to actually get that to stop. So I'm going to remedy this by going into player controller, because I'm going to add a new input. So I'm going to put all the inputs on player controller. So let's do after. After our get access, we can do if detect an input dot, and we'll get a key. We'll get a keyboard key. So I'm just going to hit escape to. Basically, what I'm going to do is I'm going to pause the game, and that way I can have control over my cursor again. So get key down. So this gets the first time you touch a key, not like every frame. Get key would be like every frame that you hold it down. So, oh, they have a good example here. Think auto fire. So if you have a machine gun game, then you would hold it down, and maybe it would get called with get key. So input dot get key down, and we're going to say, I don't know if we can say just escape like this. Check. So just looking it up, it's escape with a lowercase e. We can look at this by finding our project settings and I think input. No, this just has the axis. I think last time I just like tried different ones until it worked. But we can find that in the Unity documentation too. Alright, so if it's pressed down, I want to pause. And then to pause, you mess with time, and you set the time scale equal to 0. But the problem with this is if I press it down once, then the game is paused, and it'll be paused forever. So I actually want to check if the time scale, we'll check if it's equal to 1. If it's normal game, then we'll pause it. Else, so the time scale doesn't equal 1. Then we'll revert the time scale. So this means else the game is paused. Then we want to set that back equal to 1. So if I set it equal to 2, we can just try this out. It should run super fast because the time scale is doubled. And I hit oops, I didn't hit escape yet. Hold on, escape. It's paused. It's kind of fun. I can still move my character around. If I pause again, it's super fast, right? Where's pause? Maybe something's not working. Where's my pause? Oh, yep. It's because I hit 2, and it's checking if it's 1, and it's not ever 1, because it's always timescale 2. This should solve it. We're just doing normal timescale and a pause timescale. So normal, pause, great. We could have some, like, we can prevent this happening, like keep have a setting where if the game is paused, then don't move the player. But there could be some interesting mechanics with this where we pause, like maybe there's 2 circles, and the only way to get from one to another, because it's blocked off, is to pause and then move and then unpause. It'd be kind of fun. So I'm just going to leave it because I think we can make that an interesting mechanic. I also want my cursor back. But if we do that, then we have to, yeah, we can do that. So on escape, then we'll make cursor visible again. Timescale 0. Make cursor visible. And I actually need to surround this with brackets. I didn't surround it with brackets before because I don't need to if I'm only working with 1 line of code. So that's a little trick there. I'll just keep this consistent and everything will have brackets. And then cursor.visible. So we want it to be invisible when we're going back into the game, and we want it to be visible when we pause. That way we can get our cursor back. It'll still follow our cursor, but we'll have it here so we can just more easily like press pause. That way we're not trying to find our cursor. Okay, so we've remedied our little problem playtesting by adding a new input. We got a little off track, so let's get back to, we had a fail state, so why don't we, actually we can't navigate to our win state, which is this little warp hole, quite yet. So it's not really in the center of the circle, so I'm going to move it like 2. It's maybe 1.5. I like that there. Yeah, that's good. So we won't do our win state yet. We currently in our game manager we have we only have 1 target and 1 speed, and that's we need to navigate through a maze. We're gonna have to change targets and speeds several times. So instead of just feeding in 1 target, I can do this. I can make this array simply by adding 2 square brackets. And now target is array that holds a bunch of targets and a bunch of transforms. And speed will be an array that holds a bunch of floats. So now it's going to complain because this is an array and it doesn't have a position. It doesn't have 1 position, it has several positions. So we need to think of how we're going to go through our array of targets. First we want to fill the array. So we want to, we can just do this in the editor. We can make another target, so we can test this out. A map, we can, our target, where is this at? So if I hit W, I like to see this like this. Did we change the map or something? Oh, that's why. I moved the map when I didn't want to, and that's why our warp hole is all in the wrong spot. 0, that's better. Now our target, I like that spot. I'm going to duplicate this, and now I have another transform, and so right here is where I want to shift again. I was considering putting one here and here, but basically the game would be like, I'd just make sure not to move the cursor at that point, keep it centered. So I'm just going to go directly from here to the warp hole spot. So we have 3 positions, and to keep this organized, I'll just create a parent object. For these empty objects, I like to keep them at like 0, 0, 0. So I'm going to say these are targets, and we'll put all 3 of these in here. And anytime we move the map, we want to move the targets relative to that. So I'm just going to make targets a child of the map. So that's nice. And if we go into our game manager, this should be, we have an error, so we can double click the error. Oh, I put the brackets on speed instead of float. So we want an array of floats called speed. And also we have this error, so let's just comment that out for now, so that we can clear the errors. And now you can see that these are now arrays. We can specify the size of this, which we have 3 targets in the scene. So I'll press 3. And then this should match our target size, because we're going to increment through these in our code. So now that we have an array of targets, we need to change this function to work with whatever our current target is. So we can make an integer. We won't make this public, so I'll move this up. Integer current target. I might want to shorten that. No, it's okay. That's fine. So now we can reference our target array with whatever space we want to refer to, whichever target we want to refer to, with the current target, and get that position. And then our speed, whatever our speed, it's the same current, oops, oh man, current target. So that's fine. We're not changing current target yet, so it'll always be 0. And we haven't put in our targets, so we might as well do this. So I'm just going to drag and drop the first, second, and third target into spot, and we set the speed to 0, and so it wasn't moving at all, and it had an error. So we can make this a speed of, I think we had 5 before, right? So we'll just keep that at 5 and see how that goes. The scale is off, and my speed is super high. Oh, right. We had noticed before that we needed like 0.5 speed. Since we're only referencing the first one, 0, this is default 0, and we can actually say 0, just to make sure it starts that way. So in our update, we want to increment through our current targets depending on if we've reached or not. So we can, basically we need to check, did we reach target? If so, next target, right? We'll move to the next target. So before we move on, I want to take a look at this translate line from before. So this worked because the camera starts at 0, 0. So wherever the position, we're feeding in a vector and multiplying that by time and the variable speed. This worked because whatever position we had of a target on the screen was going to be the same as the vector we want for the direction, because the camera starts at 0, 0. So that's not going to be true when the camera starts moving around. This won't be accurate. So what we need to do is, I don't know why there's so many parentheses here. We can get rid of one of those, but I'm gonna subtract the position of the current target by the camera position, and then the next thing I'm going to do is this vector can be either large or small. So we're translating by the vector and the speed, so this is actually going to, if the distance is larger, the speed is going to be greater for the camera. So I am going to normalize this, and that just means that any vector that's normalized, the x, y, and z can't be larger than 1 or negative 1. And so since the vector is normalized, then the speed will be standard throughout. Okay, now that we have this, now let's go back and let's code this next target. So what we could do is we can check if the camera position and check, is it equal to the target position. So target, current target, dot position, and if it's equivalent, then this is unrelated. Then we can go to the next iteration on here. So we can say current target plus plus, right? Because that's shorthand for current target equals current target plus 1. So I need, what is component? Oh, not camera, cam dot position. All right. Okay. But the reason this is not okay is because this vector is going to be working with very specific decimal numbers like we see here with the player. And the chance that these are going to match exactly is pretty small, even though that the camera is being translated to that position. So we want to actually specify a range. We can make this a public range, public float. We'll make it a target range. And so now we're going to say if the target position, just like we did before, subtracted by the cam position, And if that is less than the target range, then we can increment the target. But since these are vectors, we need to check for x and y, and since this is a float, we can say if target position dot x minus cam position dot x. And there's also one thing to look out for is that this can be a negative number. So if it's a large negative number, it's still, if it's a large negative distance, it's still going to be less than the target range. So we want to make this an absolute value. So we're going to do math f. It's a library from Unity, and that's that first one, absolute value. So we're taking the float absolute value of whatever the difference of this is, and if it's less than the range, then we can add to the current target. We can see if this works. Let's try it out. We're moving really slow because I didn't adjust the speed. It's okay. Oh, let's not maximize this and let's see what's happening. I think I know what's happening. So if we look in 3D, look at the camera, it's -10 away, and we can see the viewing little rectangle there. And if we hit play, and if I navigate this correctly, you may notice that the camera is actually inching closer and closer to that position, because we, in the depth-wise, because in our code we're making the camera translate exactly to a position, which is where the z is 0, and if we want to keep the map and all the targets in the player, if we want to keep that at 0, then we need to adjust for the camera. So one cheap fix for this is if I create an empty object, and we'll just call this camera holder, and we move the main camera into here. Now in our code, if we instead of moving the transform of the main camera, we move camera holder. Is that space or no space? No space, so we'll say no space. And we specifically make this camera holder, oops, I don't want to make that 0, 0, 0. Whoops, 0, 0, and then parent the camera. I want this to be -10 from this. So when I instead of moving the camera, I'm moving the camera holder around, and so this, when this equals this position, main camera will still be -10, and we can see everything. So quick fix for that. And while we're at it, let's change. Oh, those speeds are here, so we're good. Speed is 5, so maybe we'll speed it up to like 10 or 8 or something like that. And when we're in a certain range, I don't know what's happening here. Current target, so current target has gone up. Let's make this public so we can see what's going on. Oops. Since we're restarting the level, that does make it hard to actually go through this and pause. And actually we need the game managers because we're looking at the current target. So yeah, the current target is not incrementing up, so this is never being called. Oh, our target range is too small. Doy. Okay, let's make that 1. So for within 1 space, then we can move forward to the next target. There we go. And I guess our next target was so maybe I incremented 2. Oh, we're only checking the X. So we need to check for both the X and the Y. So we'll check. We're just going to copy this. And we're going to do our logic and. So both of these have to be true. So it has to be within X range and Y range for it to move to the next target. Oh, well, I almost got to the end, but I don't have a win condition anyway, so it just would have stopped there. There's one thing that I like to just be neat. So I'm gonna move this inside the brackets. I want to snap to the position if we're close enough. That way I can know that when the camera moves around and it reaches its target, that not only is it near its target, but it's actually exactly at that position. And we can just be neater, and so that the camera doesn't move wonky. So we will also set the cam position to be equal to the target position. So target num, not current target, dot position, and we want to call this before current target is incremented, because we want it to be the one that we're at, not the one we're going to. So great, we'll snap to the target for 1 frame. What next? I suppose we can make a win condition. So we'll go to warp hole, add a component, we'll add a box, we'll add a circle collider since it's a circle. You can see there, and I think that's actually a good range, so we can focus on that. Great, so circle position, and I'm going to make this a trigger because I don't want to actually collide with this in any way. I don't want anything to collide with it. And we're going to do just like we did with the map. We're going to create a script that sends a message to Game Manager that says, and I'll call this warp hole controller. Create an ad. And instead of using start and update, we're going to just use, instead of on collision enter, we're going to use on trigger enter. So void on trigger enter. And instead of using, oh, this is 2D, make sure it's 2D. So instead of using a collision, we use an actual 2D collider. That's the main difference between on collision enter and on trigger enter. we actually use a collider here, so we can call that coal still though, because we're referring to the other collider. And we can still do, we can check the tag, so if call dot game object dot tag is equal to player, then if that's true and that's true, we want to game object dot find game manager, and we'll send a message which says win instead of fail. So in game manager we're going to have a similar similar function to fail, so actually I'm just going to copy and paste, and instead of red we're going to turn the map green. Map sprite dot color color dot green, and instead of reloading, oops, that's going to be called win. Instead of reloading the level, it's like load next level. So we can get active scene dot, let's see, instead of feeding in the name, we can feed in the build index. So when we actually build this, we will go to build settings, and we'll specify all of the scenes that we want. So the next level we make, we'll add another scene. So I'm going to add this up. So level 1 is going to be index 0, and we want to load scene, and we're going to do +1. So the next one after the current active scene. We don't have another scene right now, so we'll just comment that out for the moment. Just change it to green, and we can test it. I hate the speed. Let's change the speed. Let's make it 10, 5, 10. Yeah, it's fine. So much faster. Rotate around. Okay, it's snapped, as you can see. I might make that range just a little bit smaller so that so this is update. Oh, one thing. We're getting this little error because we've incremented the current target. However, the size of our target array is only 3, and so after the third target, once it's reached the target, it increments again and it throws us an error. So I'm going to put this all inside another if statement, and this is going to check if our current target, that's the number for what increment we have, if current target is less than less than the target array's length, so that'll return how many spaces, what our size was here. So we specified a size, so it'll return this number. So as long as it's less than that, then we'll do all this translating and what have you. And we put all of this inside that bracket. Okay. Actually made the scale. Alright, I'm going to pause because I don't like the scale being that big. Yeah, I was going to change the snap too, so let's make it a target range of 0.25. That should be good enough. So we'll have to just be a quarter's length in between. Yeah, so the snapping isn't so great now. Or it's not so noticeable, I mean. Great, and we've reached a target. We're still out of range. Oh, I see. So actually the order of events here is a little messed up. So we want to let's have this line ahead of our check. So we're going to translate into our direction. This is only going to really matter on our last target. So we want to reach the target and then check for the position and increment. And then once we increment, then this will be higher than the target length, and we won't call this anymore. So this was called, right, so we called this and we were at the current target, so we incremented this once, and we called this one extra time than we meant to. So moving this ahead of the if statement will fix that little error that we have now. Alright, so we have, did I miss anything? We have our fully functioning base game now. I can travel through here. It's a speed of 5 now, and then speed of 10. And I'm getting pretty good at this. I'm going to do some rotations. Yay. Alright, so next time we'll put a little bit of polish into this game and make it a little more snazzy.